Hello, hi everyone. Hope you all are doing well. In today's class, we will discuss about trust. Okay, so we will have some basic idea about trust. We will not go too much into the theory part, but our main motive of today's class is to understand how to solve for the forces in different members of a truss by using method of section, method of joints. Okay, so these are the two basic thing which you need to know, because in civil engineering or mechanical engineering, the first year or second year would definitely have a question where you need to solve a truss using method of section or method of joint, where you need to solve for the forces in the member of a truss. Okay. So, what is a truss first of all? Okay. So, you might have seen truss anywhere, so at many places. Okay. So, suppose if you have a train bridge, okay, and if you see a steel member like this, okay, so this is nothing but a truss. Okay. So, trusses are formed by members connected to one another, okay, and these points where they are connected are known as nodes or joints. Okay. These nodes and joints are generally pin jointed, and hence there are no movement at this point, and trusses would only have axial forces. Okay. The member would only have axial forces. So, suppose this is the member of truss, okay, it would only have an axial force. This axial force may be compressive or may be tensile. Okay. So, the axial force in a truss are maybe compressive or tensile. These forces in the member, these axial forces in the member, that is what we are supposed to find. Okay. That is what your university will ask you. Okay. So, let us begin with a simple example. Okay. We will just take one single triangular frame. Okay. But in your examination, you will have something like this, okay, where you will have multiple triangular section. But to have an understanding of method of joint and method of section, first we will take this simple example. We will go through the basics, how to solve for method of joint, how to solve for method of section. Once we acquire all the basics, then we will go to this question, okay, the second one, which is probably what you will have in your examinations. Okay. So, let us do this now. So, first of all, to solve a truss, first you need to see in this truss you have two supports, right. There is a support at A, there is a support at C. Okay. Now, so you need to find, because since there is support there would be a reaction, so I will write RA and RC. The first step in solving for method of joints or method of section, you can take any one of these method to solve for the forces in the member. Okay. So, I will teach you both the methods. Okay. Now, to solve for this method, the first and foremost thing what you are supposed to do is to find the reaction, that is RA and RC. To find the reaction, you have to go through the equilibrium equation. Okay. So, to find the reaction, you need to go through the equilibrium equation. Now, what are these equilibrium equation? Generally, you have three equilibrium equation, that is summation of forces in x direction is equals to 0, summation of forces in y direction equals to 0, and the third one is summation of moment at a point is equals to 0. Now, while taking summation of forces in x direction equals to 0 or summation of forces in y direction equals to 0, you need to know the sign convention. Now, what are your sign convention? When you take summation of forces in x direction equals to 0, take rightwards positive, forces going towards right as positive and forces going towards left as negative. You can take either way, okay, you can take left as positive, right as negative, it is up to you. Similarly, when you take summation of forces in y direction equals to 0, you can take forces going up as positive and forces going down as negative. You can change this. Okay. So, you can also change this. Now, summation of moment at a point is equals to 0. You can take clockwise positive, anti-clockwise negative. Okay. So, you can take clockwise positive and anti-clockwise negative. Okay. So these are the three equilibrium equation which we will generally use throughout the process. Okay. So first thing first, we need to calculate reactions. Okay. So see, I have drawn this triangular frame again. In this triangular frame, there is a 5 kilonewton load which is coming from up. So what I will do is, I will start with summation of forces in y direction equals to 0. So summation of forces in y direction equals to 0. Whatever is going up, I will take positive, and whatever is going down, I will take as negative. So Ra is going up, Rc is going up, and 5 kilonewton is going down. So minus 5 kilonewton equals to 0. So what we have here, Ra plus Rc equals to 5. Now I will take the next equilibrium equation, that is summation of moment at point equals to 0, right. So which point should I take? Either I should take at point A or I should take at point C. You can take any one of these 2 points. So I will take summation of moment at A equals to 0. So what are the moments at A? There is a reaction Ra which is passing through point A, and any force which are passing through the same point where you are trying to find the moment is 0, right. So moment due to the force Ra is 0. Okay, what is your moment? Moment is nothing but force times distance. So the force is Ra, the distance is 0. So the moment because of Ra is 0. Then what is left out? The 5 kilonewton force. The 5 kilonewton force is at a distance of 3. This was 3 and this was, the vertical height was 5 and this was 3. So if you see the line of action of 5 kilonewton, it is at a distance of 3 from A and it is generating a clockwise moment. So I will write 5 times 3, since it is clockwise I will take as positive. Then I have Rc which is at a distance of 6 meter and it is anti-clockwise. So what I can write here is minus Rc times 6 is equals to 0. So if I solve this, this would be 5 times 3 15 minus 6 Rc equals to 0. If I rearrange this, I will get Rc is equals to 15 over 6, which is nothing but 2.5 kilonewton. So once we get Rc as 2.5 kilonewton, we can get Ra also. Put this Rc as 2.5 in equation, the above equation, this one. Okay, you can plug in this value in this equation, Ra plus Rc equals to 5. Plug this in here. So you will get Ra plus 2.5 is equals to 5. So you will get Ra as 2.5. So this is the first step. The first step is to calculate the reactions. Okay. Once you have the reaction, then you can proceed further to the actual process of method of joint or method of section. So first I will explain how to solve using method of joints. Okay. So first you need to plug in this value. How much is your Ra? Ra is 2.5. Similarly, Rc is also 2.5. So we will start off with method of joints. Okay. So calculation of forces using method of joint. Okay. So this process is known as method of joint. Now in this process, what you are supposed to do, first select any one of the joint. Now here, if you see, we have 3 joints. One is your joint A, another one is joint B, and another one is joint C. So I will take joint A first. Okay. If I take joint A, what all forces are acting on this joint A? On joint A, I have a force of Ra, which is 2.5 kilonewton. Then I have a force in the member. This member is joining the A. Okay. So I have a force in this member, which I can write this force F. I will represent force as F, and force in this member A to B. I will write this as A to B, and I will write here force in this member from A to C. Okay. So I have a force in the member A to B and I have a force in the member A to C. Okay. So initially I will consider this force going outwards. Okay. If I get a negative value while calculating this force, then I will change the direction. Okay. So this is your assumption. You can take anything. Okay. You can take inwards, outwards, it is up to you. If you get a positive value, that means your assumed direction is correct. If you get a negative value, that means you have to change your direction. Okay. So, this is the basic thing. Let us move ahead. Okay. So, first thing, consider initially forces going out. That this is what I have explained you just now. I have written this. You can go through this statement again. Okay. Now, you can change this direction if the forces are found to be negative. That is what I have written here. Okay. Now, before we go any further, we need to find this angle. What is the angle between these two forces? Why you need to find angle? Because this force FAB is inclined. It is neither vertical nor horizontal. So, you need to find components. Okay. You need to find components. So, the component would be, with the angle would be FAB cos theta, and without the angle, that is vertical component, would be FAB sin theta. So, you need to know theta. So, for finding out theta, you can use simple trigonometry. You know the vertical height was 5, you know the distance, the center distance was 3 meters. So, you can take tan theta. What is your tan theta? Tan theta is opposite by adjacent. Okay. So, tan theta would become, opposite is 5 and adjacent is 3. So, theta is tan inverse of 5 over 3, which is equals to 59.03. Okay. So, this is the value of your theta. Okay. Now, once you have the theta, then you will do the same steps which you have done earlier. Okay. What are those steps? Using equilibrium equation to find these values. So, first I will do summation of Fy. Summation of Fy. If I do summation of Fy, what all forces are going up? 2.5 is going up, plus FAB sin theta is also going up. So, both are positive. Anything else you have? No, you have nothing else. So, I will make it equals to 0. So, this would become FAB is equals to negative 2.5 over sin theta, which means negative 2.5 over sin 59.03, which is equals to, you will get negative 2.915 Newton. Okay. Now, since it is negative, okay, since it is negative, wait a second, let me check the units first. It is in kilonewtons. Okay. So, it is in kilonewtons. So, yeah. So, you can write 2.915 kilonewtons. Since it is negative, the initial assumed direction is incorrect. So, what you are supposed to do? You are supposed to change the direction. So, initially I have assumed the force FAB is going out, but now see in my diagram what I have done here is I have made FAB 2.915, but it is coming inwards. See, the direction has changed. So, I have changed the direction. This is what you are supposed to do. The second thing, what is FAC? You also need to find FAC. For that, since I know it is FAC is acting horizontally, I can take summation of forces in horizontal direction. So, if I take rightwards positive, that means in the above equation only I will do. So, FAC is going right, FAB cos theta is also going right, is equals to 0. So, my FAC is equals to negative FAB cos theta, which is negative, FAB is negative 2.915 cos theta cos 59.03. So, your FAC is equals to 1.5. So, if you calculate this in your calculator, you will get 1.5, which is positive 1.5 kilonewton. Since it is positive, there is no need for changing the direction, and hence you can see here with my green highlighter, the direction of the line I did not change. Okay. Now, the second thing you need to know, forces in a member of a truss are equal and opposite. What do I mean by that? Forces in the member of truss are equal and opposite. For example, there is a force like this which is coming towards A. So, the another force would be towards B. They would be equal and opposite. So, you have a force AC which is going out of A. So from C also you will have a force which is coming out of A, they will be equal and opposite. So here you had 2.915, so here you will have 2.915, and here you had 1.5, so here you will have 1.5. This is known as equal and opposite. So in a member, that is member A, B, there is 2.915. Similarly, in the member AC, there is 1.5 which are going out. Okay. Okay, so this is known, this is what I meant by equal and opposite. So AB, if it is going down, so if it is coming towards A, then it would be BA should be towards B. Similarly, if you have AC, if it is going out of AC, then again it should go out of C. Okay. Now there is only one member force which I don't know, that is the force in BC. So I need to calculate what is the force in BC. Now to calculate force in BC, what you are supposed to do? Same, you need to take the joint C. Okay. So this is the this is the joint C. Okay. So at joint C, if this is the joint C, so your forces, summation of forces in y direction equals to 0. So what would be the forces in y direction? FCB sin theta is going up plus 2.5 is going up is equals to 0. So FCB is negative 2.5 over sin theta was how much? 59.03. Yeah, it was 59.03. If you solve this, you will get negative 2.915. Since it is negative, you have to change the direction. Okay. So since it is negative, since FCB is negative, change the direction. So initially we have considered this going out of C. So finally what you will do? You will plot this entire diagram. Okay. And this time you will not plot going out, you will plot inside because it was negative. Okay. Now, which forces are tensile and which forces are compressive? Now, in your trust, okay, in your trust, if the forces are going away from the joint, if the forces are going away from the joint, they are known as tensile forces. If the forces are like this, they are known as the member is in tension. If the forces are towards the joint, this is compression. So in our case, the top two are in compression because the forces are going towards the joint, and the bottom member, which is A to C or AC, the forces are going away from the joint, hence it is in tension. So this is the final diagram. So this is the method of joint. Whatever you have done till now is method of joint. So I will just give you a small recap. What is method of joint? You will take a joint, you will resolve the forces, and you will use equilibrium equation to find the forces. If your value of force comes out to be negative, you need to understand whatever direction you have assumed was incorrect, change the direction. Finally, you need to draw the complete diagram showing the values of forces and nature of the forces. Values of forces are 2.915 and 1.5 and 2.915, but the nature also you need to tell whether they are compression or in tension. Nature, how you can tell? If the forces are away from the joint, then it is considered to be tension. If the forces are acting towards the joint, then it is considered to be compression, as I have shown you in this diagram. Okay, then let us move to method of section. Now for method of section, what you are supposed to do? For method of section, you just need to cut a section out of the structure. Okay, so you can draw a line, you can create a section. Say suppose this is section XX, cut this section XX. So if you cut this section XX, you will have this side of the portion. If you see this side of the portion, what you have? You have a force of 2.5. Okay, you have FAB and FAC, because once you have cut, a force will come out of that. Now, since FAB is inclined, there would be two components of FAB as shown here. See here, I have drawn this here, FAB sin theta and FAB cos theta. Now, what you are supposed to do? Do the same thing. You have to do summation of forces in y direction equals to 0, that is 2.5 is going up plus FAB sin theta is equals to 0. So, FAB sin theta is equals to negative 2.5. So, FAB is negative 2.5 over sin theta sin 59.03. If you remember, it is the same question, only I am solving it by method of section. So, angle will not change. So, I am not finding angle again. Okay. So, you will get FAB as negative 2.915 kilonewton. So, you need to change the direction. So, the direction of FAB would be changed and it would come towards inward. Okay. Similarly, you can do summation of forces in y direction equals to 0, summation of forces in x direction equals to 0. If you do this, you have FAB cos theta plus FAC is equals to 0. So, FAC is equals to minus FAB cos theta, which is minus of minus 2.915 times cos of 59.15. So, you will get FAC as positive 1.5 kilonewton. Okay. So, since it is positive, you do not need to change the direction. So, what is happening at joint A? At joint A, there is a force which is coming towards the joint A and it is equals to 2.915, and there is a force which is going away from the joint A which is equals to 1.5 as mentioned here. Okay. See, you can see there you got the same values by method of joint and method of section also. Okay. So, method of joints you got the same values, method of section you got the same values. So, if in the examination they do not mention which method you need to take, so you can choose any one of this method, whichever you feel easier or whichever you are comfortable with, and you can solve, you will get the same answers. But if in the examination if they ask you solve the truss using method of section, you need to solve by method of section, you should not solve by method of joint. Okay. That is why I am teaching you both the methods. Okay. So, this is all about method of section. Similarly, you can draw one more section. Okay. This is the point C. Now, use this section, this side of the section. Okay. It would look something like this. Solve, you will get the same answer as method of joint, same values, and then you can plot the final answer. Okay. Now, this example is really basic example, a simpler version, but in the examination you will not get such a simple truss. You will find a truss something like this, which has so many triangular components. So, let us solve this example.